So any doubt till now? Any doubt till now, beta? Hello. So we have done all this acid, basis, and salt. Any doubt till now? Anything that you think it is a problem you want to discuss, or else we move to the next chapter, or even in this chapter, is there anything left?
So I think we didn't do the salt, the baking soda.
I think हमने baking soda, washing soda.
Baking
ठीक
soda
है.
is okay. So we have not done the baking soda part that you are saying. Okay, let us go to the
Yes, sir.
baking soda part first.
So we have not done plaster of Paris as well.
The compounds basically, isn't it? The compounds only.
Okay.
So important compound that we will talk about. Basically, that is the salt that we are going to talk about, isn't it? So in that salt, we have to study what? We have to study baking powder or baking soda. We have to study plaster of Paris and so. So what is baking soda? Haven't we discussed that thing? What is baking soda?
NaCl3.
NaCl. Okay. Let me take the book also the reference. So we have done the metals now. Oh, sorry, not metals. Sodium hydroxide, sodium chloride, family of salts. Okay, let us start with the. We have completed the pH. Okay. Now chemicals. Let us take first sodium chloride. The first compound NaCl. So this is given in your this book. This book is Manjit Singh. Okay, so we will follow this thing, Manjit Singh only. So what NaCl? What is NaCl? NaCl is a salt. I have already did all this thing. I am trying to correlate what is given in your book and what we have discussed. The first thing that we should know about NaCl is preparation and how we can prepare it. So preparation. How to prepare this thing? Simply by adding NaOH to HCl, isn't it? Plus what? Here. Is it okay? Now, what else that we require? Here preparation is there. So here there will be a liquid and this is a solid form. It will be in the dissolved form. So it is aqueous. Now, how to obtain NaCl from this aqueous solution? What shall we do? So, from aqueous solution, we can obtain NaCl dry. How? By evaporation. The method is called as evaporation. So by just evaporating the water, by heating it, हेलो हाँ सर हाँ चितरपुर में आ जाएगा 500 आगे okay so evaporation is there because of evaporation the water will be out and you will get NaCl which is a dry solid form. Is it okay? This is how we can prepare NaCl.
So in exam, do we write H2 in the with the arrow, or do we write plus H2 in gas form?
Sorry.
So in exam, do we write H2 from the arrow of evaporation, or do we just write in the product side?
Evaporation, you can just write evaporation. This is the logical part. We have to define it. The dry NaCl can be obtained by evaporating the water by heating the solution. NaCl solution obtained. Something like that. Okay. This is something which is idea flow diagram. You can say where ideas are getting generated. Okay. Next thing is what they have written is this is the common salt. So what they have written is the common salt, which is nothing but NaCl. Now, common salt is NaCl, but there are some impurities also. So the common salt can be obtained. It can be obtained or obtained from because we know that all the chlorides basically they are other than 2 or 3 are soluble, therefore the source will be water bodies, so that they can be obtained from seawater or they can be obtained from rock salt.
So the rock salt which they obtain is dry, yeah.
Yeah.
So the rock salt is naturally dry, yeah. It is not actually.
Naturally occurring substances there. They are the naturally occurring source of NaCl. Okay. So these two are the sources that we should remember. So how to get it? how to get it, how to evaporate it. So here what we will try to accumulate the water in some small pond sort of thing. We'll dig out some holes, put the water there, the basically the solution, seawater there. The water will slowly evaporate because of sunlight, and so because of energy from sunlight, and the remaining thing will be the salt. Okay, the dried salt. Are you getting a point? Just write it down. Method of obtaining common salt from seawater. Right? Seawater is trapped in large seawater हाँ. तो वहीं आएंगे ना सर, वहीं पे आएंगे ना, घर पे आएंगे तो वहाँ तो घर से नहीं पहुंचते. Sorry, write down. Seawater is trapped in large, shallow pools. Large, shallow pools, and allowed to stand there. The water gets The water gets evaporated. Due to sun's heat. And the common salt is left behind.
Sir, can you repeat from beginning once more?
Okay. Seawater is trapped in large, shallow pools. So what they will do, they will make some pools out of it. Okay. They will take out the seawater, put it there, and completely fill it. Leave it there. So what is going to happen? Slowly and steadily, the sun heat will be sufficient to evaporate all the water, leaving behind the common salt. So the seawater is trapped in large, shallow pools, allowed to stand. Why shallow? Because if you will add more water, then all the water cannot be evaporated as such. Okay. Large, shallow pools and allowed to stand. Full stop. The water gets evaporated from sun's heat, and the common salt is left behind. Okay. Next point, from rock salt. rock salt. So here this has been, the salt is like, here is mining is done. So this rock salt is obtained by mining operation. So what we are doing? We are doing mining operation. We are taking out, similar to coal, you can say. Just like what we do for coals, similarly we are doing here. So they are basically the underground deposits. So they are present in the nature as underground deposits. How they have been formed? Very simple. So we have underground deposits in our earth crust. Some salt would have been trapped. Okay, due to high pressure, they will be forming something like a rock sort of thing. So when you are trying to dig it out, this salt, this rock sort of thing will come out. And this contains, this is slightly brown in color, brown in color, brown or brownish black, you can say, due to impurities. Due to impurities. Okay. How they are formed? Because of some seas would have been evaporated, they have been dried out and evaporated. Because of that, ancient seas will be there. Because of that drying out, the salt will be there. And because of so many years have passed, these rocks, these salts have been entrapped in the earth crust. Okay, is it okay, beta? Any doubt? Any doubt?
No, sir.
Simply just what I can say, I can just dictate that, that's all. So uses NaCl or common salt. What are the uses of NaCl? We are saying NaCl, but it is common salt. What are the uses of NaCl?
It's used in food, cleaning, purification,
Purification of what?
water.
Okay. Or you are adding water, you are adding NaCl for purification of water. So it can be used for preparation of important compounds, chemicals, like NaOH. Like NaOH. They can be used in NaHCO3 and so on. Other things, very important food ingredient in food for taste. As food preservative.
So just one doubt.
So
Yeah, how will we prepare NaOH from NaCl?
when we electrolyze NaCl,
Oh yeah, yes.
hydrogen and oxygen comes out, and Na plus and OH minus. Okay, these are left behind.
Yes, sir, understood. Yes, I recall.
So they are used as preservatives. Example in pickles. In pickles, what in manufacture of soap. So in manufacturing of soap, whatever is given in a book, that's all. And they can be used for cleaning, melting ice, or we can say snow. For cleaning of roads, in very in countries where there's heavy snowfalls. So what is going to happen? All the roads will be just covered with snow. So one thing is there, they have some truck sort of thing that can take out the snow. Another thing is that they sprinkle NaCl or calcium chloride. So what is going to happen when NaCl or calcium chloride is sprinkled over a snow? The melting point decreases to such an extent that this becomes liquid at the given temperature and gradually it flows out. Are you getting my point? Melting slow ice that have accumulated on roads in cold countries. In cold countries. Then written.
Yes, sir.
So this is all about NaCl. Let us take another example. Let me first follow the NCRT also. What are things that are given in NCRT? That will be easy for me. Otherwise, there's so many things that is given in different books which are not very important as such. Just okay. So we have completed this one. Now let us do decay more about salt family of salts, pH, chemicals. Now next is sodium hydroxide. Sodium hydroxide. The second part. Okay. So what are the things important for that? First is what is called as it is called as caustic soda. Called as caustic soda. It is called as caustic soda. Formula, we all know that formula is formula.
I read it somewhere that NaOH is soda lime, not caustic
Soda
soda.
lime.
Yeah.
No. Soda lime is NaOH plus CaO.
Oh,
So soda lime is a mixture. It's not a simple compound.
okay, sir.
Okay.
Yes.
So how to make compound? Preparation. How to do this? Just remember electrolysis of aqueous NaCl solution. NaCl solution, which is also called as brine solution. This solution or brine. Okay, this is the brine. Now, what else that we have to understand? The reaction part of this. So when we have NaCl, brine solution, because I've taken a brine solution. This is the aqueous NaCl of brine solution. Okay. So these two are basically the electrodes, something like switch, and suppose this thing. This is a positive charge, this is a negative charge. So this negative charge will be called as what? This will be called as cation moves to cathode. So this cathode, and this is your anode. Okay. This is the electrode that we are talking about. Okay. Now, what happens is at cathode, what will come out? At anode, what is going to come out? So at cathode, the hydrogen gas will be evolved. You can write here hydrogen gas evolves. At anode, chlorine gas is evolved. And here you will get Na plus ion, OH minus ion. So here you are going to get what? NaOH in the solution. NaOH in the solution. Okay, there is some sort of time barrier here. No issue. Okay, beta. Is it okay? Say yes or no.
Yes, sir. Okay. Perfect.
What is the reaction? The overall reaction is we'll have 2 NaCl plus water, NaOH plus Cl2. Electrolysis, after electrolysis, this is the reaction. This is the okay. Balance it out.
Sir, a doubt.
Yeah.
So brine is basically common salt and water.
Brine solution is a solution of common salt.
Okay, sir.
Okay.
Yes, sir.
This is the reaction that is taking place. Okay. So we have covered everything. You can write it also. Just write it down. During electrolysis of brine solution, during electrolysis of brine solution, that is sodium chloride solution. Sodium chloride solution. Chlorine gas is produced at the anode. Chlorine gas is produced at the anode. Anode means what? Positive electrode. And hydrogen gas is produced at the cathode. At the cathode. Full stop. All the three products, hydrogen, chlorine gas, and NaOH, are very important products. Write it down. All the products, chlorine, hydrogen, and NaOH, are very important products. Next line. Next line. The process of electrolysis. The process of electrolysis of sodium chloride solution of sodium chloride solution is called as chlor-alkali process. Chlor dash alkali process. Why? Because chlorine and alkali, NaOH is both are formed. Chlor-alkali process, because of the products formed. Because of the products formed. That is chlor, CHLOR, chlor for chlorine, chlor for chlorine, chlor for chlorine, and alkali for sodium hydroxide. Okay, sodium hydroxide. So next line. So the three very useful products obtained from chlor-alkali process. Chlor-alkali process, that is electrolysis of brine solution. Are sodium hydroxide, chlorine, and hydrogen. Sodium hydroxide, chlorine, and hydrogen. I have written it again just to make you understand. Don't get confused if the word chlor-alkali comes in your mind or in your paper. Okay. So what are the uses of H2? Right, the uses of H2. H2 as fuel for making fertilizers. That is ammonia for fertilizer. For making ammonia for fertilizers. For making margarine. For making margarine.
So for making?
For making margarine, margarine.
So vegetable oil, yeah.
Pista butter.
margarine.
So I just had a question.
Yeah,
So if H2 is used for making ammonia, right?
yeah,
That means through Haber's process. Right?
yeah, very good.
So but the thing is, this ammonia can decompose as well. Right?
The
So
decomposition
can
is
set
higher
temperature.
temperature. The conditions are different.
Okay, sir.
Yeah. Temperature conditions are different. Anything can decompose. CaO plus CO2 will form CaCO3. That is happening at room temperature. But CaCO3 on heating will give you CO plus CO2. That happens at 1000 Kelvin.
Okay, sir.
Okay. So uses of chlorine. These are all given in NCERT. Use of chlorine for water treatment. Water treatment. For water treatment. Treatment of water in swimming pools. PVC, polyvinyl chloride, PVC, which is a plastic, no? Pesticides for making PVC, pesticides, chlorofluorocarbons, CFCs, chlorofluorocarbons, CFCs, disinfectants, disinfectants. Okay. Next, use of NaOH. Use of NaOH for making soaps and detergents. For making soap and detergents. Manufacture of paper. Manufacture of paper. For making artificial fibers. Artificial fibers. Such as rayon. You can say rayon. For degreasing metals. Greasing. Degreasing metals. Metals, oil refining, metals.